Good day, stat students. So today we're going to talk about section 2.5, measures of position. Now, I'm just going to warn you that this video goes for a while, so you might have to cut it up into little chunks here, okay? And I'll just kind of warn you that. So what are measures of position? Measures of position, basically what we're doing is we're isolating one value and we're comparing that one value to the rest of the values in the data set. So how does one particular value compare to the other values in your data, okay? So there's three measures of position. You have quartiles, percentiles, and they're very much related to one another, and then you have z-scores, okay? And here's the thing, is that after we get through percentiles, the reason why this takes so long, this one, is because after we get through percentiles, we're going to take a break and talk about the IQR, the interquartile range, and the box plots, those things that we skipped over because we didn't have enough information to talk about them. So we're going to go back to them, talk about those, and then we'll talk about z-scores. And so that's why it's going to take a fair amount of time to get through this. Quartiles. So they divide a ranked or ordered data set into 4 equal parts. And so if you're going to divide something into 4 equal parts, how many actual dividers do you need? Do you actually need 4? No, actually you only need three dividers, okay? You only need and so we're going to call these things Q1, Q2, and Q3. You only need 3 dividers, all right? And so just to show you on a graph here, so we have Q1, Q2, and Q3 down here. And so basically what's happening here is if that was a straight line, we have 25% of the data here, we have 25% of the data in here, we have 25% of the data in here, and we have another 25% of the data in there, and that's what's happening with the quartiles, separating it into 4 equal parts. Okay. So Q1. About 25% of the data is smaller than it, and about 75% is greater. All right, and so you can see that on our graph here. So you're at Q1 down here. Okay, you got 25%, right, of the data that's before it, and 75% after it. How about Q2? Q2, about 50% of the data is smaller than it, and about 50% is greater. What's another name for Q2? Can you think of another name for Q2? Hopefully you said the median. The median. Okay, the median, Q2, they're interchangeable. Q3, about 75% of the data is smaller than it, and about 25% is greater. All right, so it's the opposite of Q1. All right, so to find the quartiles, you would go ahead and order the data set. You would rank the data because you got to go find the median Q2. That's the first thing. Second thing, Q2 has now separated the entire data set into two equal parts as far as the number of observations goes. All right, so go find if you go find the median for the data before Q2, you found Q1, and then if you find the median of the data after Q2, you found Q3. All right, so sometimes it's just easier to demonstrate versus saying it in words. So let's demonstrate. So find the quartiles for the following data. So here's our data, but since we have to work with Q2, the median, is this how we're going to have to work with the data? No, we're going to have to do what? We're going to have to order the data. We're going to have to rank the data. Okay. So I have the ranked data on the right-hand side. All right. And so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9. N is odd. All right. That's telling us what? Do you remember what happens when N is odd? The median is going to be an exact value in your data set. Okay, so we have 0, we got 50, so we're going to start crossing things out until we get to that middle observation. Okay, and 14. Okay, there's the median. There's Q2. Okay. All right. So now there's in finding Q1 and Q3, you always leave out the median. Always leave out the median when you're finding Q1 and Q3. So what I mean by that is that we're going to go ahead and find the quote-unquote median from 0 to 10, leave out 14, and we're going to go ahead and figure out the median from 20 to 50. And again, leave out 14. And that'll give us Q3. So if we were just finding the median for these 4 numbers, we would cross that one out with that one, and we would average these 2 numbers, right? And we would say the Q1 first quartile is what? 7. Because we would average 6 and 8. So in parentheses, 6 plus 8 divide by 2 would give us 7. So 7 would be Q1, Q2 would be 14. About Q3, can you tell what's going to be Q3? So we would have to average those two numbers. So we would put it in our calculator if you had to. 30 plus 35, that was going to be in parentheses. Divide that by 2, and I think you're going to get 32.5. And so notice what the quartiles did here. So Q1 is sitting right here, Q2 is right there, Q3 is right there. Okay, now I know it got a little messy, but notice what it did here. I'll go on this side. There's 2 observations here, 0 and 6. Skip Q1. 8 and 10. Skipped Q2. 20 and 30. Skip Q3. 35 and 50. There's 2 observations there. So what it did was it separated the data set into 4 equal parts, where each part has what? 2 observations. Okay? Next example. Here's another example, but now n is 10 and it's even. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is even. So here's our ranked data set, and we'll go ahead and start crossing things out. So we have 3. I'll try to be a little bit neater here. 3 and 72, 8 and 50, 14, 37, 17, 26. We're down to 20 and 22. We got it down to the final 2 observations, right? And so what are we going to have to do with those 2 middle observations? We're going to have to average them. It looks like Q2, the median, is 21. And it's literally sitting in between those 2 values. Okay. Now here's where to pay attention. I told you to leave out Q2 from the calculations for Q1 and Q3, but I did not say to leave out the values that we used to calculate Q2. In other words, you're going to leave out 21, but you're not going to leave out 20 and 22. So you're going to go ahead and figure out the median from 3 to 20, and you're going to figure out the median from 22 to 72. So include the 20 and the 22. Okay? So, let's see here. So we got 3, 20, got 8, 17. Looks like 14 is Q1. Can you tell what Q3 is going to be? Let's start crossing things out. Looks like 37. There's Q3. Okay? Notice what it did here. Remember, leave Q1, Q2, and Q3 out of this. You have two observations here, 2 observations here, 2 observations here, 2 observations here, and there you go. Okay? Separated the data set into 4 equal parts. Okay? All right. How about percentiles? Percentiles separates a data set into 100 equal parts. So in all practicality, it should only be calculated for large data sets. The only reason why to separate a data set into 100 equal parts is because you have a large amount of data, okay, like thousands or millions or even billions of pieces of records, okay? And so if you have billions of observations, okay, might be a good idea to go ahead and calculate the percentiles. No reason to do it for a data set of only 50, okay? So since it's meant for very large data sets, we will not be calculating percentiles. No reason to, okay? However, we should know how to interpret them. Why? Because you're going to run into this in everyday life at some point in time. Probably already have, okay? Just make sure that you're able to interpret these, though. So, for example, you scored in the 86th percentile ranking for the ACT. First of all, did you do well? All right. And 2, how did you fare versus everyone else that took that particular ACT? So to answer this is that, yeah, you did extremely well, okay? And why? Well, since you were in the 86th percentile ranking, you scored higher than about 86% of all takers of this particular ACT. And that also means about 14% scored higher than you, okay? But for the most part, you did pretty well, all right? And so once you have that percentile ranking, that means you know what percent of the observations are before that value. You know what percentage is after, okay? Because the percentile ranking gives you the percentage of data that is lower than it. So if you're at the 35th percentile, you know that you did that 35% did worse than you, okay, and that 65% did better than you, okay. So percentiles. Okay, we have enough information now that we can go back to the IQR. So the IQR we like to put on a computer, and interquartile range doesn't fit too well, and so this is where we get the IQR, interquartile range. So the IQR is the range in the middle 50% of the data. So here, back to our demonstration with the bell-shaped curve here. What it's doing here is that here's Q1, here's Q3, and so remember what the range is. Range is maximum minus the minimum, max minus minimum, but it's the max minus the minimum for the middle 50% of the data. And where's the middle 50% of the data? It's in red here. Okay, here's the middle 50%. And so what's the maximum for the middle 50%? Q3. What's the minimum? Q1. So that's what it's telling you, is that basically the difference between those two values. And what is it lopping off? It is not considering anything in white here, because that is that's neither one of those is the middle 50% of the data. So it pretty much ignores that data. It just looks at the middle 50%. So like I said, the IQR is Q3 minus Q1. There's our formula. Okay, and the IQR is a measure of variation. Okay, and it goes along with this list. Remember this list a while ago in Chapter 2? We have the range, we have the standard deviation, and then we have the IQR. Okay, so it's a measure of variation. Now I've gone ahead and put it on a graph that is skewed right, and it's a little bit more useful here. And so I think Q3 is going to be Q2 is going to be somewhere like right around here. That was supposed to be a straight line. So you got 25% of the data here, you got 25% of the data here, you got 25% of the data here, you're going to have 25% of the data here. Okay, and just as a reminder, what is going to be located out there? Since this is skewed right, what's outliers? Okay, so you have the potential for some outliers out here. Okay, and so notice here, since we're only looking at the data from here to here, what is it lopping off? It's lopping off this, it's lopping off the white over here, and so what is it going to lop off? It's going to lop off the outliers. Okay, in other words, the IQR is completely resistant to outliers. Okay, hopefully you can see that with my simple little demonstration right there. Okay. So, as a rule of thumb, and you should know this for the exam, this will be beneficial to you, is that if the data contains extreme outliers, okay, what you want to use measurements that are resistant to outliers then. So, for a measure of center, what measure of center is resistant to outliers? Median. So if you have extreme outliers and you know that it's going to distort the mean, you can't use the mean, you're going to use the median. Well, how about for a measure of variability? The standard deviation is not completely resistant to outliers, so we're going to want to use the one that's most resistant to outliers, which is the IQR. Okay, but now this is only for if the data contains extreme outliers. Okay, you would use that. So when we ask you which measure of center should you use here, well, ask yourself, does the data contain extreme outliers or not? If it does, okay, use the measurements that are resistant to outliers. If it doesn't, what are we going to use instead? For all other situations, so in other words, if the data does not contain extreme outliers, for a measure of center, use the mean. For a measure of variability, use the standard deviation. And this is what we use most of the time. Most of the time we do not have extreme outliers in our data. Okay, and so the way we're going to usually analyze this stuff is with means and standard deviation. Okay, box plots. All right, so box plot is a plot for quantitative data, and it goes with the list where you have the histogram, stem and leaf, dot plot, and last was the box plot. Okay, so we have this idea of what's called the 5-number summary for a data set. And all the 5-number summary is that it provides the minimum along with the quartiles and then the maximum values. Okay, that's all it is. So why did I bring this up is because a box plot is a graphical representation of the 5-number summary. So not alone, so here's the cool thing. I know it's probably not cool to you, but with regards to the box plot, not alone does it give the minimum, the quartiles, and the maximum, it also gives shape, it gives the range, it gives the IQR, and also gives the outliers. Yeah, so it starts to identify outliers. Okay. So what I think I want to do is, I usually don't draw these too often for students. I allow the computer to do this, but I think the box plot is complicated enough that we should probably draw this once, okay? And hopefully once we draw it once, it'll be easy to interpret all the other ones, okay? So let's say that we had this following data. We had to create a box plot for it. So we already know what the minimum is. Minimum is 0. Maximum is 50. We already identified that. And I think if you go through this, I think you're going to find 10 is Q2, the median. So we got 1, 2, 3, 4, 5, 6, 7 observations there. 1, 2, 3, 4, 5, 6, 7 observations over there. And I think you're going to find out that Q1 and Q3 are 3 and 19 respectively. Okay, so notice we have 3 observations here, 3 observations here, 3 observations here, 3 observations here. If you need to go through the steps, go ahead and go through the steps. But there's Q1, median, Q2. The IQR, what would be the IQR in this situation? The IQR would be, let's see, Q3 minus Q1, that would be 16. Okay, so we got to remember 3, 10, and 19. Okay, and then we can calculate the IQR to get 16. Okay, we're going to have to remember those. All right, so what's going to happen is that we're going to go ahead and fill in Q1 and Q3. Oh, hold on, and Q2, sorry, and Q2. So we got Q1, Q2, and Q3. And so all we're going to do is draw a straight line up and down at each one of these. And so here, that's 3. That's 10. That's 19. Okay, so we would just go ahead and draw a line straight up and down at the quartiles, and then we would connect the tops to make a box. Okay. So what you got to remember is that no matter what box plot you are working with, this left edge will always be Q1. This middle line will always be Q2. This right edge will always be Q3, no matter what. Okay, Q1, Q2, and Q3. Next, we have to identify outliers, okay? And so we have this idea of what's called a lower fence, and I'm just going to put LF for lower fence. And these help us identify the outliers, okay? Lower fence. And lower fence, how do you calculate it? Lower fence would be Q1 minus 1.5 times the IQR. Okay. And so the lower fence, there we go. And so we know these values. So let's calculate the lower fence. So let's see, Q1 was, I believe, 3 minus 1.5 times an IQR of, as I recall, 16. So we got to follow the order of operations here. So we got to do 1.5 times 16 first. We get 24. So we get 3 minus 24, and you get a negative 21. Okay, so the lower fence is off the screen because this is 10, this is 0, negative 10 here, negative 20, negative 21 is probably somewhere out here. Okay, so the lower fence is way out here. Let's pretend it's like sitting way out here. Okay, right at the edge of the screen. There's the lower fence. Okay, then we have the idea of what's called an upper fence. So we have a lower fence and an upper fence. So I just got to change some minor things around. Okay. The upper fence, so UF, the upper fence, is Q3 plus 1.5 times the IQR. And so Q3 was 19. So we got 19 plus 24. That gives us 43. Okay? And so at 43, let's see, where would 43 be? Right there, I don't know. Say that's 43, okay? Doesn't matter if I got it right or perfectly or not. Computer has it correct. So we got 43 right there. So what that means is that any observation that is outside that fence here and outside the fence over here would be considered outliers. Okay, so the upper and lower fences are identifying outliers. Anything outside these fences, outliers. So if you go back to the data, I believe we had an outlier at 50. Thus, the computer is going to go ahead and put some sort of dot here to represent 50, an outlier at 50. Okay, if there was another observation out here that was an outlier, it would go ahead and put both of them. Okay, but here we just have one observation that was outside the fences. Okay, then the last step is that we have to draw these whiskers here. Okay, this used to be called a box and whisker plot. Sometimes I still see that. Okay, and so what's happening here is that, so we had the fence at 43. Okay, and what this is representing here, this is, I'll say this slowly, this is the maximum value that's still inside the fence. So I think if you go back to your data set, I think you're going to see 35 is the maximum value that's still inside the fence. Maximum value that's still inside the fence. What do you think this represents over here then? This represents the minimum value that's still inside the fence, and that was 0. Minimum value that's still inside the fence. Okay? So now, be careful with this. Students get tripped up on this all the time. So, if we ask you for this data set, what's the 5-number summary? Okay? You would say minimum would be 0. Okay? Now, why would this be the minimum? Because you did not have an outlier out here. So if you had an outlier, say right here, at say a -10, then the minimum would be a -10. This would not be the minimum. That would be the minimum. But we did not have an outlier, okay? And if you don't have an outlier, then this line where it stops, that would be the minimum. So you have to sort of be careful. This is always Q1. This is always Q2. This is always Q3. Now, notice what's happening over here. This is not the maximum. This is the maximum, your most extreme outlier. Your most extreme outlier is your maximum. So that would be at 50. Okay? Now, if you did not have an outlier, okay, that's gone. Let's say that's gone, and that would be the maximum now. But we did have an outlier, and so the most extreme outlier then would be your maximum value. Okay? So, how about if, what would things look like if, one other thing. Okay, one other thing, I'm sorry. What I needed to talk about here is, let me get rid of some of these lines anyways, that'll help. That what's going on here is that I want to go ahead and show you shape now. Okay, so what is the shape of this data? Can we tell by our box plot? Okay, and so what you got to realize is that students often translate this incorrectly. From this point right here, the minimum, to this point right here, how much, which is Q1, how much data is always there? It's 25%. It's just that it's very compact. Okay, it's very compact. So there's 25% of the data from here to there. And then you got 25% of the data that's a little bit more spread out. And then you got 25% more that's spread out. And then you have 25% that goes from there all the way over to the outlier. Okay, and so if I had to draw a curve here, probably the median, I sort of botched it up a little bit, but it probably would look like something like that if you drew a histogram for it. Okay, and so clearly we have a skewed right distribution. So this box plot is telling me it's skewed right. what kind of box plot would look like if it was nice and symmetrical and probably bell-shaped. Something like this, where from here Q1 to Q2 is roughly the same distance from Q2 to Q3, and then from the minimum to Q1 is roughly the same distance from Q3 to the maximum. That's telling us that we have something symmetrical, and it very well could be bell-shaped. Now, in order to see bell-shaped, you might have to go ahead and look at a histogram or a dot plot or a stem and leaf. Okay, but here we can certainly see that it's symmetrical, and chances are it's probably going to be bell-shaped, but you never know until you actually take a look at it from a histogram standpoint. How about skewed left? What would skewed left look like? Well, all right, so this would be skewed left. Remember, this is still Q1. This is still the median, Q2. This is still Q3, these edges of the boxes. Okay, and this is the maximum now. There's no outlier out there, so this is the max. Okay, this is not the minimum. This would be the minimum, that most extreme outlier. And what's happening here is that we have 25% of the data from here to where? Is it here, or it's all the way to here? So from here to there, you have 25% of the data. Okay. Then you have 25% of the data from here to there, 25 from there to there. Then you got 25% from there to there. All right. And where's it most compact? It's most compact inside of here. And so notice that the distance from here, which is the maximum to Q3, is very different than the distance from Q1 to the minimum. Okay, it's getting spread out this way. All right, so we got a lot of data over here. Okay, and it's getting spread out that way. So clearly we have a skewed left distribution here. Okay, so shape. Let's see here. Again, you can identify the IQR. The IQR is the length of these boxes. Remember, Q3 minus Q1, and so the length of this box would be the IQR. So you can go back to this one. The IQR would be from the length of the distance between Q3 and Q1. Same with this one. IQR, all right, would be from there to there. Okay, so you can tell the IQR. You could tell the range from here to there, minimum, right? Maximum minus the minimum. Okay, maximum minus the minimum. So notice outliers: Q1, Q2, Q3, minimum, maximum, skew left. Okay, so on and so forth. So you can get a lot out of a box plot if you look at it and get pretty good at it. Okay. If you need to take a break, please take a break.